So here we have three examples of the next carbonate mineral on your list, which is aragonite. You'll notice that it has the same chemical formula as calcite does, and this is because they fall under different crystal systems. So the first thing that I see when I look at aragonite is the crystal form and the habit that it likes to grow in. So at first glance, this looks very hexagonal, right? It's got a great hexagonal shape to it. And then even if we look at this sample here, you can really see these kind of hexagonal forms, but I'll tell you that it's all a lie because this sample is not, this mineral aragonite is not in the hexagonal crystal system. It's actually in the orthorhombic crystal system. And what we're seeing here is a function of 6 twins that have grown together to form these really nice crystals. And there are some giveaways as to this as well. You can see we have this line that goes right down the center of those two faces. Likewise, we have a growth right here on this center, another line in between this, and that's because these crystals are almost like wedges, and there are 6 of them growing out together. We even have another twin right here on the top as well. So it's lying to you. It's not hexagonal, but it almost always grows in these beautiful hexagonal, pseudo-hexagonal forms. This one, when we look at it as well, it has that same kind of intergrowth. This is really common form for aragonite. This one here I've chosen because it looks a little bit more like coral. Even when I'm holding it, it's really light, low density, because we have these kind of fibrous crystals. This organic looking kind of structure, it's literally coming off on my fingers. This organic looking structure is really common for aragonite. Having these almost little shard crystals coming off of it, really common. It looks like we have like a skeletal structure. If something looks like a piece of coral on your mineral exam, I almost guarantee you it is probably aragonite. So we've talked a lot about crystal form and the habit that it likes to grow in. The next thing, we are in the calcium carbonate, so we have to check and see if it reacts with HCl. So I've got my bottle of HCl here. We'll go with this one. So we want to see if this reacts vigorously or not, because that'll be a diagnostic property. All right, very vigorously. This shape is not conducive, though, to keeping things clean. So I'm going to give this little wipe off here. Awesome. So it reacts vigorously with HCl, just like calcite did. Out of our entire group of carbonate minerals, this is going to be the mineral that reacts the most vigorously with calcite. The two of them together, if it's a strong reaction, it's most likely aragonite or calcite. So just like the others in the carbonate family, or the majority of them, our luster here is going to be a vitreous luster, really glassy looking. We could also have more earthy crystals, I would say, or this one would be sub-vitreous because we have some faces that don't have a really great reflection. For our streak, it would be a white streak, just like the calcite samples that we had. And the density, it's a moderate density, and it reacts really well. We've got a great crystal form. Let's check the hardness. So the hardness on this should be about 3.5 to 4. So we should be able to scratch it with a nail pretty easily. Let's give it a go. Ooh, maybe not. So I've just made a bunch of scratches there. So yeah, softer than a nail, and we'll definitely, that gave me a little bit of trouble, so I'm definitely expecting to see a good scratch on this penny here. So we gave the penny that scratch right up in the corner. So harder than a penny, softer than a nail. That's what we would expect. Moderate density. The last thing is the cleavage on here, and it has not as noticeable cleavage as something like calcite, so that's not going to be a diagnostic property we necessarily use. And that there is aragonite.